It's really important to distinguish power functions from exponential functions. So last time we talked about some examples of power functions, things like f of x equals 3x squared, d of x equals x to the fifth, h of x equals 7x to the fourth. These are the somewhat obvious ones. These are the nice ones. And then we also had ones that were perhaps not so obvious, things like a of x equals the fifth root of x. The reason this is a power function is not obvious is this is the same thing as x to the 1/5. So we have fractional powers that correspond to roots, and we have negative powers which correspond to being in the wrong place. So I have q of x equals x to the -4. That's the same thing as q of x equals 1 over x to the 4. And so we need to recognize that when we have a function that may not look like a power function immediately, if there's a power in the denominator or if there's a root, those are also power functions. And finally, we have things that may need to be cleaned up by using algebra. So if I have r of x equals x to the 4th times x to the -1, then I can use my properties of exponents, say that's x to the 4 minus 1, which is x cubed. So this is obviously a power function. This is a power function in disguise.